The relation of congruence modulus n is a equivalence relation in the set of integers. Now proof. Let Z be the set of integer. If n is any fixed positive integer, then we say that a is congruent to b modulo n if n divides a minus b. We shall show that this defines an equivalence relations on set Z. Now reflexivity. Let any integer a minus a is equal to 0 and divides 0. Thus a is congruent a modulo n for all values of a belongs to Z. Therefore the relation is reflexive. Now symmetry. If a and b belongs to Z such that a is congruent to b modulo n, thus we have n divides a minus b, which implies a minus b is equal to kn for some integer k belongs to Z, which implies b minus a is equal to minus bracket starts minus k bracket close n, where minus k belongs to Z. N divides b minus a, which implies b is congruent to a modulo n, thus a is congruent to modulo b, and which implies b is congruent to a modulo n, and therefore the relation is symmetric. Now transitivity. A and b and c belongs to Z be such that a and b, a congruent b modulo n and b congruent c modulo n. Thus then we have n divides a minus b and n divides b minus c. So n is equal to curly bracket starts a minus b bracket close plus b bracket starts b minus c bracket close curly bracket close. N divides a bracket starts a minus c bracket close, so which implies a is congruent to c modulo n. Thus a is congruent to b modulo n and b is congruent modulo to n, which implies a is congruent to c modulo n. Therefore the relation is a transitive, hence the congruence modulo n is a equivalence relations on n.